Hello guys, welcome to another video. This one is paper 1-2 of October-November 2010 for Add Math. So with that being said, let's move on to question number 1. Okay, so here we have the equation of a curve is given by y, where a is a constant, okay? Given that this equation can also be written as this form, where b is also a constant, we have to find the value of a and b and also the minimum value of y. Now, what is this form? If you know from practice or from revision, this is called the complete square form. So basically we have to try to change this equation into this form. Okay, so let's do this step by step. Now, to complete the squares, the first thing we need to do is we need to look at the coefficient of x squared. In this case, the coefficient of x squared is 2, so we need to change this to 1. So you will have y. We will take out the value of 2, factorize, you will have x squared plus a over 2 x, and then we can just leave the 14 outside. We don't really care about the last constant for now. Okay, so now we can proceed to the next step. So once the coefficient of x squared is 1, we can proceed to the following step. Now, so y will be 2 is the same. Now x squared is x squared plus the same value. Now we have to add something, and the value we'll add will be the number here, which is a over 2 divided by 2 will be a over 4, and then square the value. Now again, when you add something, you have to minus the same value so you don't change the equation. So now we have this, but again, this is inside the bracket for 2. We also have to give it 2 here. Okay, so now we have to simplify to see what you will get. So let me continue this here. Okay, so we have y equal to 2. This will become, this is x squared, that will become x. Here we have plus, that will become plus. And the value inside is a over 4. And square will be square. And then this will be what? 14 minus this, so that will be a square over 16. So that will be 14 minus a square over 8. Okay, so right now we have changed this to a complete square form. Now we have to use this to find the values of a and b. So step by step, we just have to compare with each other. So let me find some space for that. So basically what we're trying to do is, we know that this is supposed to look like this, right? Because that is y here, that is supposed to be 2, that is x minus 3 square plus b. So by comparing the values that we have, we can find the values of a and b. So first thing first, here we have plus, here we have minus. So here we have a, so this and this are the same, so a over 4 is supposed to be minus 3. So which means a has to be minus 12. Next one, here we have plus b is equal to this, so b is equal to 14 minus a squared over 8. Now, because we know the value of a already, we can just replace and find the corresponding values. That will be 14 minus 144 over 8. So let's see what you will get. 14 minus 144 over 8, that should give you minus 4. Okay, so question part 1, that will be, so let me write the answers down. So we have a has to be minus 12, and b has to be minus 4. That's the value of a and b. Now let's move on to part 2 of the question. So we have to find the minimum value of y. So there's a reason why it is only 1 mark. It is super easy. Why is that? Because whenever you change your equation to this form, you can find your minimum value directly. So let me write this down. Right now you know that your equation looks like this. Y equal to 2x minus 3 square. Here we have b is equal to minus 4, that will be minus 4, right? So now you know your equation looks like this. Now, whenever you complete the square, the value at the end is called the stationary value. It can be a maximum value or it can be a minimum value. Now, because the coefficient of x squared is 2, which is a positive value, so the value here will be your minimum value. Okay, so your answer for part 2 will be -4 for the minimum value of the equation y. And that is your question number 1. Okay, so let's move on to question number 2. Sketch on the same axis the graph of cos x and also the graph of sine 2x for the domain of 0 to 180. So that's the domain. We just need to draw the two curves and find the following answer. So pretty easy. As always, we have to make a table of values to be able to draw these curves. So let's begin one by one. Let me take blue color for cos, and I will take green for sine. Okay, just to differentiate them. So let's begin with this one. So the first x value, and we have y values. It is between 0 and 180. So I'll begin with 0, obviously. I will take 90, and then I will just take 180. So here the interval is 90, 90, if that makes sense. Now, you may ask me, why did I choose 90? The reason is because I like to work with exact values. So if you want to work with exact values, you always have to look at the coefficient of x in here. It is 1. Because it is 1, my interval will be 90 divided by this number. That will be 90. Because of that, I will choose an interval of 90 for my x for this curve. So let's try. You will have cos of 0 is 1, so the first value is 1. Then cos of 90 will be, should be degrees obviously, cos of 90, that will be 0, 0. And then cos of 180, that should be -1. So this is my table of values for my cos curve. Now let's move on to this one. For sine, we have x values and y values. Now, if you can see, I will always begin with 0 because here we have 0, obviously. But the next thing is, here if I observe, I have 2 in front of x, so my interval will be 90 divided by 2. That will be 45. In this case, I would choose an interval of 45 because this will help me to find exact values of y to plot my graph. That's the reason why I choose those values. So I'll have 45, 90, 135, and then 180. So you have sine of 0, that will be 0. Sine of 2 times 45, that will be sine of 90, that will be 1. Sine of 180, that will be 0. Sine of 270, that will be -1. Sine of 360, that will be 0. As you can see, we have the values for both curves that we need to draw. Now let me draw the y-axis and the x-axis. Let me do this here because we don't have space. So that's one is done. Let's proceed with question number 2. That's the curve for this. So we have the y-axis. Of course, you will be using a ruler for this. Don't just draw it like I am doing. You'll have to use a ruler for this. This is x, and this is your y value. The values will be between 0. So we have, let's say I'll choose 90 here, and then I will choose 180 here. And this is the value of 1 and the value of -1. So again, it is only a sketch. It doesn't need to be exact. We just need to show the form, the shapes to get your marks. If this is 90, so in between that has to be 45, and this has to be 135. Okay, so now we are ready to draw the curve. So let's draw the first one, which is the cos curve. The cos curve is the blue color. For the value of 0, the y is 1, so first point is here. For the value of 90, the value is 0 here. And then for 180, -1 should be somewhere over here. That's my cos curve. Now let me plot the sine curve as well. So we have 0, 0. 45 will be 1. Then we have 90 will be 0. 135 will be -1. 180 will be 0. Okay, so let me join my sine curve first. So that will be. So of course you have to join them by a smooth curve. It's not a straight line, obviously it's a curve. So try your best to make a curve of these points. That will be my green curve. And for this one, it has to be a curve as well. And you will be drawing with a pen, with a pencil, not a pen. So that if you make any mistakes while doing this, you can always erase them and then retry again to make your curve look smooth. Of course, you have to label them. This is the green one, which is sine 2x. And the blue one has been given by cos x. Of course, you can write equal to y or equal to y. It's the same thing. That is my answer for part 1 of the question. Okay. Now for part 2, hence write down the number of solutions of this equation. Okay. Now, whenever you see hence, you see this word hence, it means that we have to use the previous answer to answer this question. So basically, what was the previous answer? It was a graph. So we have to use a graph in some way to answer this question. But now if you observe, here we have sine 2x, and here we have cos x. If I send cos x to this side, what happens? It will be sine 2x is equal to cos x. Now we have drawn both curves. We have drawn cos x, we have drawn sine 2x. So we have to find the values of x where sine 2x is equal to cos x. In other words, we have to find the values of x where the curve of this one meets the curve of this one. So by using, of course, your graph. So by observation, you can see that the two graphs meets at 1 point, 2 point, and 3 points. So we have to find the number of solution, write down. So your solutions will be, number of solutions has to be 3 because we have 3 points of intersection between those two curves, sorry. So this is your question number 2. Now let's move on to question number 3. So we have to show the left hand side becomes the right hand side. As always, we have to proceed step by step. So here we have one fraction plus another fraction. So as you can see, the base are different. So here we have 1 minus sine x, and here we have 1 plus sine x. So they are different bases. So how do you solve addition between two fractions which have different bases? You will first have to change the base to make it become the same. And one way of doing that is to multiply them by each other. So this multiplied by this will be 1 minus sine x times 1 plus sine x. Next step is to cross multiply. So once you multiply them, you have to cross multiply. So cos x times this will give you cos x plus cos x sine x. And this by this will be plus cos x minus cos x sine x. So let's simplify this. So this will cancel out. As you can see, here we have plus cos sine minus cos sine, so they will cancel out. So on top you will have 2 cos x over this value. Now we have to find a way to simplify this. Let me write this here. If you observe, if you would know this, so we have this, let's say we have a minus b multiplied by a plus b. This is the difference of squares. We know this should be a square minus b square. Now the same logic applies here as well. If you observe, we have 1 minus sine x multiplied by 1 plus sine x. So that will give you 1 square minus sine square x, which should be cos square x, according to your identity given to you on your formula sheet. So that will be cos square x. Now just simplify, this will cancel out, this will be this. So you'll have 2 over cos x, which is equal to 2 sec x. This is shown as required for your question number 3. Now let's move on to question number 4. So here we have to factorize completely the expression given to you. Now, as you can see here, this one is a cubic curve. When you have to factorize a cubic equation, you have to find the factors of the equation. So to find the first factor, you have to find this by trial. And by trial, you have to look at this last number here, the constant. So let me write this down on a new page. So basically here we have, let me break this down. So we have our main equation, which is f of x. Let's call it f of x is equal to 2x cubed minus 11 x squared minus 20x minus 7. Now to find the first factor, we have to find this by trial, and we have to look at this last number, which is minus 7. Now what are the factors of minus 7? It could be minus 1 times 7. It could be 1 times minus 7. So these are the factors of minus 7. So now we have to test those values one by one to see for which one the remainder will be 0. For example, I can first begin with this one. So f of, let's take the value of x to be minus 1. Let's see what happens. So 2 times minus 1 is minus 1, right? Minus 11, that become plus 20, minus 7. Okay, so 2 times minus 1 is minus 2, minus 11 plus 20, minus 7. That should be 0. So this is good news. Because the remainder is 0, we conclude that the value of x is equal to minus 1. F of x is 0, which means the remainder is 0. Now, because of that, we can find the factor pretty easily. We just have to send this one over here, and the factor could be found. So x, when you send minus 1 to the other side, become plus 1. This will be a factor of that expression. So now, since we have this factor, we can find the remaining factors by doing long division. So let's do that one by one, okay? So we have 2x cubed minus 11, x squared minus 20x minus 7. Then carry on with the long division. Let's see what do we get. That will be x plus 1, and then we will have 2. Do this one by one. So first, how can you make x become 2x cubed? You have to multiply by 2 and then x squared. So that will become, this time this will give you 2x cubed and then plus 2x squared. So this will cancel out, and then we have to minus, right? So minus 11 minus 2, that will be minus 13 x squared minus 20x minus 7. Now same question, how can you make x become minus 13x squared? You have to multiply by minus 13x. That will give you minus 13x squared minus 13x. So this will cancel out. So minus 20, minus minus become plus, so minus minus become plus here. Minus 20 plus 13, that should be minus 7x minus 7. Now how can you make x becomes minus 7? Have to multiply by minus 7, right? So you will have minus 7x minus 7, and that should always give you 0 for this long division because it is a factor. So when you have a factor, long division will always give you 0 here. So now because we have done this, we can realize that f of x can also be written as x plus 1 multiplied by this one, 2x squared minus 13x minus 7. So now we have to factorize completely. So this one is good. We have to factorize this part. Now if you observe, this one is a simple quadratic equation that we need to factorize. So 2 brackets. So 2x squared is what it is, 2x times x, right? And 7 is simply 7 times 1. Now we need to find the value of minus 13. To get minus 13, we have to have minus 14 plus 1, right? So finally, in this case, we have realized f of x is factorized completely to x plus 1 times 2x plus 1 times x minus 7. This is the complete factorization for f of x, for this function actually, that is given to you. Okay, so that is your question number 4. Okay, now let's move on to question number 5. So here we have a curve have equation y. The curve passes through the point P. Okay, that is given to you. Good. Question number 1 is we have to find the value of a in terms of this. So pretty easy. When you have a passing point, this is called your x value and your y value. Just replace these values in your main equation. So y will be a, and then x will be just 2 pi over 2, sorry. That's x times sine pi over 2 plus pi over 3, right? Now we can just simplify. So that will be cancel out. You have pi here. What is sine pi over 2? We have to use radians. Sine pi over 2, that is 1. So that will be times 1 plus pi over 3. So which means a is equal to 4 pi over 3. That is your value of a in terms of pi. Okay, that is part 1. Now let's move on to part 2. Using my value of a, you have to find the equation of the normal to the curve at P. So now we have to understand what exactly we are looking for. We are trying to find the equation of the normal. Now we have to go back to draw something if you don't understand. Let's draw something to know what we are looking for exactly. So let me make some space here so we can see what we can do. Okay, so let's see. For example, we know the curve have equation y equal to 2x sine x plus pi over 3. That's the equation of the curve. And we have a passing point which is pi by 2, and the value of a was found to be 4 pi over 3. Right, that is the point P, and also we have the value of y over here. Now we have to find the equation of the normal. Now let's make a drawing to know exactly what we're trying to find. So for example, it doesn't need to be exact. Let's say my curve looks something like this. We don't need to know exact shape of my curve. Let's say the point P is somewhere over here. This is the point P. Okay, now again, the normal to the point P is actually a line that passes at 90 degrees at this point. So if you were to have a tangent at this point, this normal here, let's call this n, it has to be at 90 degrees to your tangent. So you have to find the equation of that line n that you're trying to find. Now again, what is a line n? It is a straight line. To find the equation of a straight line, you have to find the gradient of the straight line. And now to find the gradient of the normal, you have to find the gradient of the tangent. Okay, so let's proceed with that. So let's first find the gradient of the tangent so we can find the gradient of the normal. Okay, so how would you find gradient of tangent? So you have to know something, as always. Gradient of tangent is always equal to dy by dx. Okay, so we have to find dy by dx from our main equation. So let's do that. So dy by dx will be what? 1 by 1. Here we have 2x multiplied by sine x. It is a product, so you have to apply your product rule. So we have to leave the first one by itself, 2x, times d by dx of sine x, that will be cos x, and then that will be plus sine x times d by dx of 2x will be 2, and this will become 0. We don't need that part. This is dy by dx. Right. Let's simplify. That will be 2x cos x plus 2 sin x. That is my dy by dx. Now we want to find the value at the point P. The point P, right? P is pi by 2. And then we have 4 pi over 3. Now we have to find the value of dy by dx at the point P. This is your x value and your y value. So let's replace the x value in the dy by dx to find the actual gradient at the point P. So you have 2 multiplied by pi by 2 cos pi by 2 plus 2 sine pi by 2. So this will be 0. We can check. So cos pi by 2 will be 1. Pi over 2, 0. So everything will be 0. And here you will have, this is 1. So that will be 2. So we have confirmed that the gradient of tangent is equal to 2, which means in turn the gradient of normal have to be minus 1 over 2. So now we know the gradient of the line. We also know the passing point, which is p. We can find the equation pretty easily. So that will be what? The passing p is obviously the point is p. Sorry, the passing point is p. That will be 4 pi over 3. And this is your x value and this is your y value. So the way I like to find the equation of a line, I will take y minus the corresponding value over x minus the corresponding value equal to the gradient of the normal. Now you just have to cross multiply. You will have 2 y minus 8 pi over 3 is equal to pi over 2 minus x. Now you have to simplify, and then this is your equation of your normal for question number 5. Okay. Okay, so let's move on to question number 6. So we have to find in ascending powers of x the first 3 terms in the expansion of this function, giving your answer in the form of a plus bx plus cx squared, where a, b, and c are integers. Okay, so what are integers? They are whole numbers. So basically, if I tell you minus 1, it is an integer. If I tell you 2, it is also an integer. So it needs to be whole numbers. So since I don't have much space over here, let me try to do this question on this page. So I have to expand, let me write this down, it is 2 minus 5x power 6. So we only need to find the first 3 terms, so the first term will be 6, choose 0. Here we have 2 minus 5x, and that will be 0. This will be 6. 6 minus 0 is 6. 6 choose 1, that will be 2, minus 5x, this will be 1, and this should be 6 minus 1 is 5. And finally, 6 choose 2, we have 2, and then we have minus 5. X, 2 here, 2 will be here, and this should be 4, right? Now let's expand or simplify one by one to see what do we have. 6 choose 0 is 1, this will be 64, and this will be 1. 6 choose 1 is 6, that will be 32, then minus 5x. And what is 6 choose 2? We can check. So 6 choose 2, that will be 15, that will be 16, and 25x squared. Simplify, that will give you 64 minus 6 times 32 times 5, that will be 960, so 960x, and plus 16 times 15 times 25, that will be 6000 x squared. So let me write my answer over here. So for part 1, my answer will be 64 minus 960 x plus 6000 x squared, where a, b, and c, they are all integers. Now part 2, we have to find the coefficient of x in this expansion. So let me write this down on this side. So here we have 2 minus 5x power 6 multiplied by 1 plus x over 2 times the power of 10. Now, we only care about the coefficient of x. So we only need the term in x. So that's what we have to keep in mind when doing this question. So this we know already. This was given by, we found it was 64 minus 960 plus 6000 x squared, and then 1 plus x over 2 power 10. Now obviously we won't be needing this term because we don't care about x squared. We only need only x, something in x. Now something for you guys to understand, for those who does not No. Let's say if I have ax, what is the coefficient of x? It is the value a. Let's say if I have 540x, what is the coefficient of x? It is the value in front, which is just 540, for example. Now we have to try to expand this. We will have 64 multiplied by 1 plus x over 2 power 10 minus 960x 1 plus x over 2 power 10. Now, 1 by 1, so here we have 64. Now, we have to expand this. Not really, we have to choose a term in this expansion that will give us something in x. So, usually we will expand this by 10, choose something, times 1 times x over 2. Now, for this term to be in x, we have to have power 1 here. If this is 1, this will be 1. 10 minus 1 is 9. Right, simplify. 64 times 10 times 1 times x over 2. That will be what? 64 times 10 times 1 over 2. That will be 320 x. Now for this one, same trick, same logic. We have 960 x. Now this term is already in x, so we have to multiply by something which does not have x in it. So we have 10, choose something, 1 and x over 2. So here we need this to be 0 because we don't want any x anymore because we have x here already. So this is 0, this will be 0, 10 minus 0 is 10. So simplify, minus 960x, that will be 1, 1 and 1. So your answer will be 320 minus 960. That will be minus 640. Minus 640x, but the answer will be only the 640 part because that is the coefficient of x. The answer is minus 640 for that part. Okay, so let's write this down. That will be minus 640. Okay, so now let's move on to question number 7. So 7, we have sets. We have two sets, A and B, such that A is defined by this condition and B is by this condition. So we have to find the elements of A and then A union B. So let's find the set of A and then we can find the set of B one by one. So what will be A? So let's solve, because we know that A is defined by sine x equal to this for this domain. So basically we have to solve for the value of x. So we have sine of x has to be 0.5. It is a positive value, as you guys must know by now. If it is a positive, it will be in the first quadrant and also in the second quadrant. This is directly your value of x, and this will be 180 minus x. Right, so x will be sine inverse of 0.5, that will be 30 degrees. And also it has to be 180 minus this, it will be 150. So basically the set of A has two elements, which is 30 and 150. That is your set of A. Now we have to find the elements of B to solve this one. So B is defined by cos x minus 30 is given by minus 0.5. Now when cos is negative, you have to know it is in your second quadrant and your third quadrant. So this will be 180 minus theta, and this is 180 plus theta. So now the reason why I put theta here is because of this negative sign. Okay, of this negative sign. So what I like to do is I like to first find the value of theta. Theta will be what? Cos inverse of the positive value of this. That's the trick here. So we don't begin with the angle directly, we begin with a fake or false angle, theta. So cos inverse of 0.5, that should be 60 degrees. Okay. But now for the actual answer, we have to look at the quadrants. So x minus 30 will be, according to the quadrants, it will be 180 minus theta. That should be 180 minus 60, that will be 120. Or it will be 180 plus, this will be 240. So x will be 150, or it will be 270. That will be here two values of x for the set B. Now question here, we have to find A union B. So basically it is the elements of A and B but not repeating the same thing. So we have 30 degrees, we have 150 and 270. It is the elements of A and B but not we don't need to put the same element twice. That makes sense. That will be part 2 of the question. Now let's move on to the part D of the question. Let me find a new page for this one. So here we have a set C is such that defined by this between 0 and 180. We have to find the number of elements in C. So this one is not as easy. We have to try to simplify first and then find the corresponding values. Let me find a new page here to solve this question. Okay, so let me write this down on this paper. So the question is, we have sec square 3x is equal to 1 for x between the values of 0 and 180 degrees. Okay, so let's solve this equation to see how many values of x do we have. Now, it is very hard to work with sec. We have to change sec to, as we guys know, sec square 3x. It is also 1 over cos square 3x. So we place this by this, you will have 1 over cos square 3x is equal to 1. We can just cross multiply, so you will have cos square 3x is equal to 1. Now we have to solve, so we have cos 3x is equal to plus minus root of 1 plus minus 1. So basically we have two possible values, so cos 3x is equal to 1, or cos 3x is equal to minus 1. But let's try to solve one by one. Now when cos is positive, it will be in your first quadrant and the fourth quadrant. So 3x have to be cos inverse of 1. So cos inverse of 1 is 0. So 3x can be 0, but also it can be, because here is 0, so here will be 360 minus the angle 0, that will be 360. So this will be also 360 degrees. So x can be 0 and 120. So here we have two values of x. Now for this one, cos is negative. If cos is negative, it will be in your second quadrant and your third quadrant. This is 180 minus the angle, and this is 180 plus the angle. So whenever I have a negative value, I like to first work with a fake angle. Basically, let's find theta is equal to tan inverse, sorry, not tan, cos inverse of the positive value of this. So this will be equal to 0 degrees. So now 3x, it is the actual angle. We will have to find this according to the quadrants. It should be 180 minus theta is 0, so that will be 180. This is also 180. Now, because we have 3x here, we have to check what are the other possible values after this. So we have to try to plus 360. That will be 540. And then we can try one more time because of the 3x, Let's see what we may have. So 540 plus 360, that will be 900. So basically, I am just testing so we don't miss any values. That is 180, 550, and then 900. So the reason why I plus 360 here and here is because the coefficient of x is 3. If it was just x equal to those values, we don't need to do that part. But now if you have 2x equal to them or 3x equal to those values, I recommend doing that because sometimes what may happen is you may miss some values. X will be 60, 540 divided by 3, that will be 180. And then that will be 300. Okay, so since x is only between 0 and 180, so this will not be included. So we will have, finally, x can be 0, sorry, and then it can be 60, can be 120, and also 180. So the number of elements in C has to be 4. Okay, that will be the number of elements in C. And that will be your question number 7. Let's move on to question number 8. So variables x and y are such that when ln of y is against ln of x, a straight line graph passing through the points is obtained. As you can see in the diagram, we have a straight line passing those 2 points which are given to you. Now, part 1, we have to find the value of ln y when ln of x is equal to 0. So pretty easy. So let's do one by one. So first thing first, what we can do is we can try to find the equation of that line, of a straight line. So again, how do you find the equation of a straight line? You first find its gradient. So gradient has to be y2 minus y1 over x2 minus x1. So let's see what we get. So 3.8 minus 5.8 divided by 6 minus 2, that should be minus 0.5. Or you can write minus half for the gradient. Now, how do you find the equation? So we need a passing point. The passing point could be any of those two. Let's say I can choose, first one will be 2, 5.8. Now, usually we call this x and y. But because here we have the graph of ln of x against ln of y, we have to call this one ln of x and ln of y. So let's find the equation. So we take ln of y minus the corresponding point over ln of x minus its corresponding point is equal to minus 1 over 2, which is the gradient. So now we just have to cross multiply and simplify. So you will have 2 ln of y minus, so 2 times 5.8, that will be 11.6 is equal to minus ln of x plus 2. So let me write this down again. So the equation of that line will be 2 ln of y. We can send this one over here actually, is equal to minus ln of x plus 13.6. So this will be the equation of this line. Now, we have to find the value of ln of y when ln of x is equal to 0. So we replace this value by 0 to find this value. So here we have 2 ln of y. Replace this by 0. So minus 0 plus 13.6. So ln of y has to be 13.6 divided by 2. That will be 6.8 as your answer. Ln of y will be 6.8. Let's move on to the next one. So given that we have y equal to ax power b, find the value of a and b. So one by one. So at first we know we have y is equal to ax power b. Now, as you can see, we have changed the x and y to ln of x and ln of y. So how can you do that? We have to apply ln on both sides. You will have ln of y is equal to ln of ax power b. Simplify, you will have ln of y has to be ln of a. We can break this down into two pieces. That will be plus ln of x power b. Now we can just rearrange. That will be ln of y is equal to b ln of x plus ln of a. Right. Something we have to know for logarithms. We can send this power to the beginning, which I did here. So b ln of x plus ln of a. Now, if you observe, this form is very similar to a straight line graph, which is y equal to mx plus c. So this is the idea here. We want to express this equation as a straight line in terms of ln, because here we have ln and ln. Now by comparison, you can see that this should be equal to this, and this should equal to this. Now what is b? b is the gradient of that line. So b is equal to gradient minus half, and c is the y-intercept, which is the value of y when x is equal to 0. So as you can see, here we have when ln y equal to 0, the value was 6.8. So which means ln of a is equal to 6.8. So a has to be exponential 6.8. That will be 898. So 898 correct to 3SF. That will be your value of a. So let's write this down. The value of a correct to 3SF will be 898, and the value of b has to be minus half. Okay, according to the equation and to the information given to us. That will be question number 8. Now, for those who don't know, why is this value? If you observe, what is ln? Ln is simply log to the base of e, right? So here we have log of e, and here we have a is equal to 6.8. So to find the value of a, we have to send this one to this side. So a has to be exponential 6.8. So that's the idea for my answer. That will be question number 8. Now let's move on to question number 9. The figure shows a rectangular metal block of length 4x. This is the length 4x, with a cross section which is a square of side x. This is a square of side x. Okay, this is pretty simple for now. The block is heated and the area of the cross section increases at a constant rate. And here we have increases. This is the rate. So basically the area is called A, right? So now we know that when the block is heated, the area, so dA, so area A increases, so dA rate is time, so dA by dt is equal to 0.003. It is a constant, so it is equal to this value. Now, one thing you have to know is that if the question says decreases, you will have to put minus, but here it is increases, it will be a positive value for dA by dt, the rate of increase of the area. Now for part 1, we have to find dA by dx in terms of x. So pretty easy. So first let's begin. What is A? Okay. A is defined as the what? With a cross section is a square of side this area A. So basically A is the area of the cross section. The cross section is a square. Area of a square is x times x will be x squared. So this will be easy. dA by dx have to be 2x. So that will be my answer for part 1. Now for part 2, we have to find the rate of increase of x when x equal to 5. So basically we have to find the rate of increase of dx by dt. So whenever you see rate, it means in respect to time, so dt. So we have to find dx by dt. So to find that, we have to use the chain rule. So let's see. Dx by dt is equal to dx on top, and here we have dt. And they are connected by area, so that will be dA and dA. So dx by dA, and here we have dA by dt. So dA by dt is equal to 0.003, right? And what is dx by dA? So here we have dA by dx. So pretty easy, we just have to flip this upside down. Dx by dA have to be minus 1. So there's no minus. Why did I put minus? 1 over 2x. Now, this is the value. Now again, when x equal to 5, so replace all the values of x by 5. That will be what? 1 over 10. That will be 0.1. So finally, we can conclude that dx by dt has to be, replace the values in the equation, so dx by dA will be 0.1 multiply by 0.003. That will be what? That will be 3 times 10 power minus 4. And x is the side, so the unit will be centimeters per second, because this is the unit of the side, x. That will be question part 2. Now let's move on to question part 3, which is interesting. So the rate of increase of the volume. So we have to find the rate of increase of the volume of the block when x equal to 5. So as always, we have to proceed with trying to find a formula for this. So what is increase? What is rate of increase of volume? So again, rate is the time, respect to time, and volume. So we are trying to find dV by dt. Now it is equal to dV. We have dV on top, and here we have dt. Now volume is connected to, it can be to x, or it can be to area. So how do you find volume of this shape? Well, you have to think. We have, it's a cuboid, so the volume is equal to length times width times height. It could be that. But usually for a prism, what we do is we find the area of the cross section and we times the length. This is how we find the area of a shape like this. That will be x squared for the area of the cross section. That will be x squared, and times the length, that will be 4x. That will be 4x cubed. So if you know v, it is in terms of x, so basically we can connect these two by dx. Okay, now, so same way, I think it's the same thing. Length times width times height, you will get the same thing. Doesn't really matter here. So let's replace the values that we need in this equation. So v is this, so we can find dv by dx. That will be 12x squared. Again, we need the values at x equal to 5. That will be 12 times 25. So let's find the value. That will be 300 for this value. So this will be 300 here. So here we have to multiply by dx by dt. As you can see, dx by dt was given to you right here. This one, ds by dt. That will be 3 times 10 power minus x. So 300 times 3 times 10 power minus 4. That will be 0.09. So dV by dt will be this, and the unit has to be centimeters cube per second, because it is for volume. So this will be your answer for question number 9, which is 0.09 centimeter cube per second. Okay, so I hope that was good. And let's move on to question number 10. The diagram shows a circle, center O, radius 4, enclosed within a sector PBCDP of a circle. So these are the information that we have already on the diagram. Now the main question here is we have to show PA is equal to 4 root 3 and then PB is equal to 12. So let's begin with the first one, which is PA. So how can you find the value of PA? Now if you observe, what can we do here is we can just try to join this and this. Join that. Now, this is pi by 3, so this has to be pi by 6. And we know this is 90 because we know that it touches at one point, which means PB or PA has to be the tangent to the circle. Now the point is we have to take this shape outside and see what can we do. For example, this shape will be what? Will be PA, something like this, right? That will be O, that will be A, and that will be P. This is 90. What is pi by 6? That will be 30 degrees. I like to work with degrees, depending on what you like to work with. It is up to you to choose. You can work with radians if you want to. Now, AO is also the radius, so this will be 4. Okay? So now we are trying to find the length of PX. Let's call this, so PA, let's call this X. So how can you find X? As you can see, we have a right angle triangle. We know one side, we want to find the other side, and we know one angle. We can use SOHCAHTOA, right? So SOHCAHTOA. So this one is called the A side, so adjacent side. And this one is called the opposite side, so that will be O. As you can see here, we have the most, that will be tan of the angle is equal to opposite side over A side, which is X. So X has to be 4 over tan of 30. That is equal to 4 over 1 divided by root 3, which is equal to 4 root 3. So basically you have to know the value of tan 30 is equal to 1 over root 3. So by knowing this, you replace here, you will have this value shown as required. Now next step, we have to find the value of PB is equal to 12. Now how can you find PB? So as you can see, if you were to find this directly, it will be kind of hard. It will be pretty confusing on how to find this directly. So we have to find a way to make it easier for us because it's only 2 marks. It should not be that hard. So one observation we make is that PB is what? PB is the radius of the circle center P, if that makes sense. If that's the radius, if I were to connect P to the point C, this is also the radius of the same circle center P. So this is the radius of the inside circle, which is 4, but this also has to be the same. So this is also 4. So we just have to find this length. So let's find the length of PO. So pretty easy. We have this shape, so same steps again. I know these steps are pretty boring, but it always helps to draw something. So we have 90 here, here we have 30, and this is 4, and we're trying to find the length of PO. As you can see, this one is the hypotenuse. We know the opposite side, we have to use sine. Sine of 30 has to be the opposite side over the hypotenuse, so PO. So PO will be 4 divided by sine 30, which is half, and that will be 8. So basically the length of PO has to be 8. So PC, so we conclude that from this, PC has to be 12, which also means PB has to be 12, because PC is the radius of circle center P, and PB is also the radius, so PB is equal to PC is equal to 12, shown as required. Now for part 2, we have to find the area of the region. So let's find that area. So how can you find this area? So let's observe. So one thing we can do here is we can break this down into 2 pieces and then find one by one. So let's forget about the top part, because as you can see, this part and this part, they are the same. We can just find for one and then multiply 2 to get the other one. Pretty easy, right? So let's do that. So look at this shape here. So here we have to first find the area of the sector PDC. So let's find that. Sector P, D, and C. So how can you find that? By using your formula, which is half of the angle here, which is what? Pi by 6. So now for you to use this formula, we have to use the angle in terms of radians. And then we have to multiply by radius square. Radius is not given, it is 12 square. Okay, so half multiplied by 1 over 6, multiplied by 144, that should be 12. That will be 12 pi. Now, for this area, because we want to minus this area, so we know that PA is equal to PE. So P is what? P should be 4 root 3 as well. From this we can find the area of triangle PED, which is half. Because it is a right angle triangle, we can just do half times base and times height. The height is 4. And that will be, let's cancel out 2, that should be 8 root 3. So finally we conclude that the area of this region here, that should be what? Should be the big area, which is 12 pi minus 8 root 3. Now this is only for this side, and we know this side is the same as this, so we just have to multiply by 2 to find the area. So 12 pi minus 8 root 3 times 2, that should be 47.7, correct to 3SF for the area of that region. Okay, so this is for part 2 of the question. Now let's move on to part 3 of the question. So we have to find the perimeter of the shaded region. Again, so how would you find that? Again, same kind of concept, but you don't need to, no big deal, I can do one by one. This is 4, this is also 4. If this is, what is this one? So if this is what? So we have P, so we need what? We need this, we need this one, we need this, and we need this. This is really easy actually. So let's find one by one. What is the length of BD? It is the length of arc, so pretty easy. R theta, R is radius. Radius will be, PD is 12, times angle will be pi by 3. That will be 4 pi. This is this one. And what is the length of ED? ED will be what? Let's find out. So ED will be what value? So we know that PD is equal to 12. So ED has to be 12 minus PE. PE is 4 root 3. Now, ED is the same as AB, so we have to, it is equal to AB. Right. Now we just have to add all the sides to find the perimeter. So P has to be what? Has to be this side plus this. So 4 plus 4, that will be 8. Plus this, we have to multiply this length by 2. And then we have to, so root 3. And then plus 4 pi for the length of arc. So 8 plus 2 times 12 minus 4, root 3 plus 4 pi. That will be 30.7 for my perimeter. So that is my value, correct to 3SF. And that will be question number 10. So we have to find the integration of that value, so one by one. So we can first rewrite this as 1 over 1 plus x power minus half, which can be written as 1 plus x, so this is plus 1, minus half dx, which is basically increase the power by 1, that will be half, divided by half, plus c. This is your answer for part 1. Let me simplify this if you want to. So it should be something that will be 2 root 1 plus x plus c. That is the integration of this one. Now for part 2, we are given that when we have 2 over root of 1 plus x equal to y, we have to show that dy by dx equal to this value. And we have to find a and b as seen here. So let's do this one by one. So we have to find dy by dx from this. So as you can see, this is clearly a fraction, so dy by dx has to be done by using the quotient rule. So first we have to write down the denominator as it is, multiply by d by dx of this one will be 2, then minus, write down the numerator as it is, multiply d by dx of this one, it will be half x plus, so 1 plus x power this value minus half. Right, and then everything divided by the base square. So this 1 plus this power 2 square. Let's try to simplify to see what can we have. So clearly this will cancel out. Here you will have 2, 1 plus x minus 1 over 1 plus x. And all this divided by this square. So simplify. So this divided by this will give you what? Will give you 2 over 1 plus this, right? And that'll be 1 over, so okay, I forgot the x here, 1x that remains, as you can see. So that will give you this, and this you will have root of 1 plus x power 3. So basically the value of a and b, A is 2 and b is this value here, minus 1. Okay, so that will be your question number 2. So let's move on to question number 3. So hence, as you can see again, we have the same word again now. Hence means we have to use your previous answer to find this value. Okay, to find this and then this. So let's do one by one. So the previous answer was what? If you were to differentiate d by dx of 2x over root of 1 plus x, right? We see this was equal to 2 over root of 1 plus x minus 1x over root of 1 plus x power 3. This is what we have found from number 2. But now, we know that integration is a reverse process of integration. Did I say the same thing? Yeah, I think I did say the same thing. My bad. I meant to say integration is the reverse process of differentiation. So what it means is, if I were to integrate this side, 2 over 1 plus x minus x over I'm supposed to get back the same value, which is this over this. So basically using this, I get this, and using that, you will get your answer to question number 3. Question number 3, we are required to find the integration of x over 1 plus x power 3. So where do you see this? If you observe, this is clearly this one. So we have to make this become the subject of formula. So step by step, we can break this down. So this can be written as 2 1 plus x by dx minus x over power 3 by dx is equal to 2x over 1 plus x. Now if you were to simplify, we can send this over here. You will have x over 1 plus x root 3 is going to equal to integration of 2 over root of 1 plus x dx minus 2x over this value. Now this, you can do this again if you want to. It is up to you, no big deal. If you want to do it again, let's do it again, no problem. So this is from part 1, by the way, but we can do this. So with this can be written as, take 2 outside, you will have 1 over 1 plus x power minus, so power half. That will be dx. That will be 2 1 plus x power minus half dx, and that will be 2 times 1 plus x after plus 1 become half divided by half plus c. That will give you 4 1 plus x half plus c. You can write this like this, plus c. So finally we place this back in here. We have realized that this is going to be 4 root 1 plus x minus 2x 1 plus x, and then plus c at the end. That will be the answer for question number 3. Now we have to solve the equation between the limits of 3 to 0. So 3 to 0 of x over 1 plus x power 3. That will be this over this 3. Now when we have your limits of integration, we don't need the constant anymore. Okay, so let's solve one by one to see what do we get. So you will have 4 times 3 will be here, you will have 2, that will be 8, minus 6 over 2, and then minus, put 0 here, you will have 4 minus 0. That will be 8 minus 3 minus 4. That will be 1. So my answer is 1 for this question, and that will be question number 11. Okay, so let's move on to question number 12. So usually you will be answering only one of those questions, but obviously I'll be doing both for you guys. So let's begin with the first one. A curve is such that dy by dx is 4x squared minus 9. The curve passes through the point. This is obviously x and y, right? 3, 1. We have to find the equation of the curve. So when you have to find the equation of the curve, it means you have to find y. And we must know by now y is actually integrating dy by dx. So that will be integration of 4x squared minus 9 with respect to x. That will be 4x cubed divided by 3 minus 9x plus c. And that is y, obviously. Now, we have to find the value of c right here. We have to use the passing point 3, 1. That is your x value and your y value. We place in your equation. Y is 1. That will be x is 3. So 3 power 3 is 27, I think. Times 4 divided by 3. That will be 36. Minus 27 plus c. So c has to be what? 36 minus 27 is 9. 1 minus 9 is minus 8. So c will be minus 8. So finally, we have what? Y is equal to 4 over 3 x power 3 minus 9x minus 8. That will be part 1 of the question. Now part 2. The curve has stationary points at A and B, okay? So we have to find A and B. So now, whenever you see stationary points, what do you think about? You think about dy by dx is equal to 0. That's the only thing you need to think about when seeing stationary points. So let me do this here on this page. So we're given dy by dx is given to you by 4x squared minus 9 is equal to 0. Now we can solve this for the values of x. So we can just factorize. So this will be 2x squared minus 3 squared is 0. That is 2x minus 3 or 2x plus 3 has to be 0. So x can be 3 over 2. X can be minus 3 over 2. Or you can write x can be 1.5 or x can be minus 1.5. Now that is one way of solving. Obviously, there's many ways of doing that if you want to. Pretty easy as well. You will do 4x squared equal to 9. X squared is 9 over 4. X will be plus minus root of 9 over 4. That will be plus minus 3 over 2. So x will be plus this or minus 1.5. So as you can see, there's 2 ways of solving. You should be getting the same values for x. Now when you find the values of x, you have to find the corresponding values of y. So as you guys know, y is given to you, as we have found, it was 4 over 3, x power 3 minus 9x minus 8. For this value of x, let's find the value of y. So x is 1.5 that's my x. So 4 over 3 times answer cube minus 9, answer minus 8, that should be minus 17. So my first point is 1.5 and minus 17. This one for y, the value is minus 1.5, so answer minus 1.5 is the answer. So we have 4 over 3, answer power 3, minus 9 times answer minus 8. That will be 1. My point here is minus 1.5 and 1. So my point A is minus 1.5, 1, and B is 1.5 minus 17. Now you may have a question is why my A is this one and not this one? It's because usually when we write alphabets, we start with A, B, C, D, E, F, right? So we know that A comes before B. If that makes sense. A comes before B. The same thing for numbers as well. If you look at 1.5 and minus 1.5, so we can see that minus come before plus. So obviously A will be representing the value before the value of B. That's why will be your values of A and B for the points. Now let's move on to part 3 of the question. So let's see what is the question. A was found to be minus 1.51 and B was, sorry, yeah, it is that actually 5.1 minus 17. Now we have to find what? We have to find the equation of the perpendicular bisector of the line AB. So pretty easy. So let's say we have a line AB which looks like this. This is A and this is B. The perpendicular bisector is a line that is passing through the midpoint of AB at 90 degrees. So we have to find the equation of line P. Now to find the equation of a straight line, we have to first find its gradient. So we know this is the midpoint. So let's first find the midpoint. It will be x2 plus x1, that will be 0. y2 plus this, that should be minus 16, divided by 2, that should be minus 8. That's the midpoint here. Now to find the gradient of P, we must first find the gradient of AB, which is y2 minus y1, so minus 17 minus 1, divided by 1.5 minus 1.5. That will be minus 6. From this, we can conclude that the gradient of P has to be 1 over 6. So if you continue, you will have y minus this value will be plus 8 over x minus 0 has to be 1 over 6. Cross multiply, you will have 6y plus 48 has to be x. So 6y is x minus 48. Let's check. So 8 times 6 is 48. So this will be your equation of your perpendicular bisector of the points A and B, of the line AB, sorry. That will be the first one of the question. Okay, so now let's proceed to the last question, finally. A curve have equation y, where x is more than 0. That's the domain by which the function is defined by. So now at the point where x is equal to 0, we have these three values. So when x is 0, we have this and this. Part 1, we have to show that a equal to 10 and then find the value of b. So one by one. So let's first replace the value of x in this one. So we know that y is equal to 50 when x is equal to 0. You have a exponential 0 plus b exponential 0. So we have 50 is equal to a plus b. That is my first equation. And then for this one, as you can see, we have dy by dx. So let's find dy by dx. So dy by dx will be what? We have to differentiate this one. A is only a constant, it is a multiple, right? This will be exponential 2x, the same, and then multiply by 2. Here we have plus, that will be b. Exponential minus x, then multiply by minus 1. See, it is 2, 2, 1 by 1. That will give you 2a this 2x minus b minus x. That is your equation number 2. Let me try to simplify this. So we know that dy by dx is minus 20 when the value of x is equal to 0. Now we minus 20, 2a minus b. So b is equal to 2a plus 20. That is my equation number 2. Now we can solve the two equations simultaneously to find the values. Replace this in here, you will have 50 is equal to a plus b. B is 2a plus 20. Now simplify. Send this over here, you will have 30. That will be 3a. So a has to be 10. Now find the value of b. B has to be 2 times a is 20 plus 20, and that is 40. So we have shown the value of a is 10 and the value of b is equal to 40. Now part 2, using the values of a and b found in part 1, find the coordinates of the stationary point on the curve. So whenever you see that, you know you have to use dy by dx is equal to 0. So let's do that. So right now we know dy by dx is equal to 2 times a will be 20 exponential 2x minus b is what value? 40 exponential minus x is equal to 0. So let's try to simplify this. We can divide by 20 everywhere. You will have exponential 2x minus 2. This can be brought down here, 0. Now let's multiply by exponential x to eliminate this value. You will have exponential 3x minus 2 is equal to 0. Okay, so you will have exponential 3x is equal to 2. Okay, let's continue this side. So 3x will be ln of 2, x will be 1 over 3 ln of 2. That will be your value of x. Let's find the corresponding value of y. Y will be replaced back in your main equation. That will be what? So y is found to be a is 10. According to this one, 10 exponential 2x plus b is 40 minus x. So that will be what? Let's see. What can we do here? So replace the value of x by this. 10 exponential 2 times x will be 2 over 3 ln of 2 plus 40 exponential of minus 1 over 3 ln of 2. Of course, you have to simplify this. Let me try to do this for you. We'll see what comes up. Usually, I think they may also accept decimal values, but let me simplify to see what can we do. So you have y 10. That will be ln of 2 over 3 plus 40 exponential ln of 2 minus 1 over 3. That will be 10. This will cancel out, and this will cancel out. So you'll have 2 over 3 plus 40, 2 minus 1 over 3. Now, you can, of course, provide the exact value, just like that, or you can simplify some more if you want to. But I like to just find the decimal. Power 2 over 3 plus 40 times 2 power minus 1 over 3. That will be 47.6 for my value. So the point is equal to 1/3 ln of 2, and we can write this one if you want to, or we can write 47.6. Okay, so that will be question part 2 of the paper. Now the last question. which is determine the nature of the point, giving a reason for your answer. Now to find the nature of the point, usually you will go with to find d2y by dx2. So right now you know that dy by dx was found to be 20 exponential 2x minus 40 exponential minus x. From this, d2y by dx2 has to be 40 exponential 2x plus 40 exponential minus x. We have to find this value when x equal to this value, so let's try to find the value. 1 over 3 ln of 2 tell me 0.231. That will be 40 exponential power 2 times x plus 40 exponential power minus x. That will be 95.2, which is a positive value. So you can write, since d2y by dx2 is a positive value, we conclude that the point, stationary point, is a minimum point. Okay, so that will be the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.